A very good morning to the class. So today we are going to speak on the week 2 lecture that is on the 13th May. It is a continuation of week 1. The learning outcome here is to understand the two misconceptions about accuracy and intensity, to be able to understand what is selection intensity with truncated selection. Number 3 is to understand what is selection intensity with threshold traits. And finally, the fourth objective, to apply generation interval in relation to realized response to selection. Now, there's a misconception as the first thing about accuracy and intensity. In animal breeding, we aim to improve the livestock population by utilizing genetic differences among the individuals. So genetic improvement is achieved by actually selecting the superior parents, and that will determine the genetic value to the next generation. Okay, so the basic mechanism underlying this process is to increase the frequency of the favorable genes in the population and to prevent genetically inferior animals from passing their unfavorable forms to the next generation. So the formula in a simple way of calculation is G equals to IR as G. I stands for intensity of selection, R is for accuracy of selection, SG is the genetic standard deviation of trait under selection, and L is the generation interval expressed in years. Now the aim of animal breeding is to genetically improve the population. So in next generation should be superior to the current generation. Now what is the challenges here? How do you choose the best animals for the next generation? And how do you know the true breeding value? So we as quantitative geneticists, we should be able to estimate the breeding value. That's called EBV. And the parents of the next generations are selected based on their EBVs. An important question is anybody can ask, how accurate is the estimation of EBV compared to true TBV? So the accuracy of EBV is defined as the correlation between the true and estimated breeding values. If the correlation shows how close EBV is to true breeding value. Now, if it's the correlation is 1, then you know it's a perfect estimate. EBV has the perfect estimate to the true breeding value. All right. Now, EBV accuracy actually influences the genetic gain from a selection program, and the genetic gain in a breeding program is proportional to the accuracy of EBVs. The higher the EBV accuracy shows that the greater the genetic gain from selection. Now, the genetic gain per year is calculated using the formula which I described earlier. All right. So it's very important to when we want to get genetic gain per year, we should intensify the selection, but at the same EBV have to be accurate. Okay, and from there we will actually focus on the additive genetic variation. The in There are many methods for us to improve the EBVs, and we will discuss about it in the next lecture. Now, what very important is when we're looking at a particular trait, we focus on the heritability of the trait. If the heritability of that trait is high, that shows the additive genetic variation is high, and therefore the EBV accuracy is also high. Now, just a recap, it's common in animal breeding to select animal means by truncation. So individuals are selected as parents only if the index value are higher than a certain cutoff, the truncation point. Truncation selection results in differences between the mean index of the selected parent and the overall population mean. This is called selection differential. Selection differential is defined as the superior of the selected parents over the population mean. So S equals to I selected minus I population. When I selected is actually the mean index of the selected parents, and I population the mean index of the population. So selection differential can be standardized by dividing it with the standard deviation index. The standard deviation index differential is called selection intensity and is expressed as I. Right? So this is where we say selection with truncated selection. This is where you have the peak, the normal growth peak, and it has a mean or index value of 100, standard deviation of 25 index point. When selecting from this population, we select a chosen group that falls on a selection index value, say 130. So this is what we call truncation point. And the distribution of this population where selected friends are indicated by the shady region. So the average index of the selection parents will be 142.2. So the selection differential is, the mean is 100, right? So 142.2 minus 100. So we will stop it here now.